6 questions that we can collectively sort of discuss and think about. So that's what it's about.
Hi, this is Ramanan, Mission Director of Atal Innovation Mission from Niti Aayog. Good evening to all of you who have logged on from India. Good morning and good afternoon to all the others who have logged on from around the world in this very, very exciting conference, global conference that we are holding over the last couple of days, the RAISE conference, which is Responsible AI, Artificial Intelligence for Social Empowerment. This is something that is very topical. Artificial intelligence is here to stay. We are having a number of technologies converging together to enable artificial intelligence actually happen and bring real solutions onto the ground. And therefore, it is my privilege and it is my pleasure to be able to invite you all to a very exciting discussion with very distinguished speakers, a session which is going to be also moderated for a panel discussion by an esteemed professor. And I'm sure every one of you are eager to listen to their views, their topics, their subjects, their opinions on something that has not been thought through much before. There is a lot of research which is being done on artificial intelligence, but we are talking about artificial intelligence for social empowerment. And so what is the research that is happening in this exciting area? And what are the potential for artificial intelligence to make an impact, not only from an economic point of view, but from a social point of view across the world? And all countries like India, for example, which is a country of 1.3 billion people with more than 715 districts, with more than 4,000 small towns and cities, with more than 600,000 villages, and with more than 44% of our country agri-economy based, and 22% of our country still below the poverty line. Artificial intelligence and the convergence of various other technologies can play a very important role in being able to bridge the economic divide, the digital divide, the social divide. But what sort of research is going on? And that is what this conversation is all going to be all about. First of all, I hope every one of you is healthy and hearty, even in the face of this very difficult COVID-19 circumstances. And all of you are following the safeguards that need to be practiced and advocated by your health authorities, by your government, or by your local institutions. We are going to have initially a keynote speech from a very accomplished and very esteemed Professor Milind Tambe, who is going to give a keynote speech on responsible AI for social research and research in AI for social empowerment. About Professor Milind Tambe, he is a doctorate from the School of Computer Science at Carnegie Mellon University. He is a professor of computer science and director CRCS at Harvard University, and is also a director for AI for Social Good, Google Research India. Professor Tambe's research focuses on advancing AI and multi-agent systems research for social good. Some of the examples of topics he has worked on include AI for conservation, AI for public health and social work, and AI for public safety and security. He is a recipient of the International Joint Conference AI John McCarthy Award in 2018, the ACM Association for Computing Machinery Autonomous Agents Research Award in 2005, and the Association for Advancement of Artificial Intelligence Robert S. Engelmore Memorial Lecture Award in 2019. He is a fellow of AAAI 2007 and ACM since 2013, and is also a recipient of the Christopher Columbus Fellowship Foundation Homeland Security Award of 2010 and several others. It is indeed a pleasure and privilege to welcome Professor Milind Tambe for the keynote speech today. Over to you, Professor Milind Tambe.
All right. Can you hear me well?
Yes, please go ahead.
Wonderful, wonderful. Well, thank you very much for the kind introduction. Thank you for inviting me. It is really an honor to be here with my fellow distinguished panelists. So I'm going to be talking today about responsible AI for social good. And just to introduce myself, I'm going to be, I am the director for AI for social good at Google Research India. And that's what I'll be focusing on in terms of the work that I'll discuss today. I'm also Gordon McKay Professor of Computer Science at Harvard, but that work I'll just discuss very briefly. All right, so with where we are with our progress in AI, it is now important to direct our advances toward societal benefits. And we can imagine many different sectors in which these advances could be directed for social good. Public health or conservation, education, agriculture, road safety, disaster recovery. I will, in this presentation, just because we are limited in time, focus on two topics, public health and conservation. So the key challenge as we cut across all of these areas that we face in AI for social good is how to optimize our limited intervention resources. I'll discuss here some work I have done at Harvard prior to my joining Google Research India. And this is ongoing work in the US and around the world. So one concrete example is work we've done with people or youth experiencing homelessness in Los Angeles. We're able to show that by harnessing the social networks of these youth and figuring out the right peer leaders, messengers, influencers in the social network with our AI algorithms, we are able to spread information about HIV prevention far more effectively compared to traditional approaches. So for example, HIV testing rates have gone up in the population when AI techniques are used to select key influencers. The key underlying research techniques, algorithmic techniques, are based on social network influence maximization and what are called bandit algorithms. With respect to conservation, the key challenge is we have large conservation areas to protect limited range of resources. In the case of the public health challenge, often the limited resources are our social workers or public health facilities or resources. In the case of conservation, it's limited numbers of rangers to protect large conservation areas. In previous work in Uganda and Cambodia, we are able to show that harnessing past poaching data, we are able to predict where poachers may set traps or snares to kill and maim animals. And for the past several years have been able to remove hundreds of thousands of these traps. This underlying technology here is machine learning combined with game theory, so-called green security games that we've developed. Today, this green security game with so-called smart partnership, which is a partnership of World Wildlife Fund and other conservation agencies around the world, we have released our software for protecting wildlife, for predicting where poachers attack, for national parks around the globe, and rangers are able to download and use this software to protect wildlife around the globe. So this is the kind of work we've been doing, have done in the past. But today I'll be focusing on the work that we've been doing at Google Research Bangalore in AI for social good. And so this is work in public health and conservation. I'll talk about our partnerships with nonprofits such as Arman and Kushi Baby, focused on maternal and child care, and in conservation with NGOs such as Wildlife Conservation Trust, which are focused on preventing human-wildlife conflict in states like Maharashtra. So as we go through all of this work, there are three common themes that you will see. First, the use of multi-agent systems. What I mean by that are techniques from social networks and game theory. Second, the idea for data to deployment pipeline. So we begin this work by immersing ourselves with the nonprofit and trying to understand their problem. We are not AI researchers sitting in our ivory towers coming up with a solution and then go looking for a problem. We want to understand first what kind of problems are really being faced and what data are actually available. Second, a predictive model is then applied to this data to make predictions about which of the cases we face are high risk versus low risk. So it's making some type of prediction. But having made all these predictions, we can't intervene on all of the high risk cases. As I said, we have limited resources. So we need this multi-agent systems reasoning to recommend actually which cases to intervene on, since we can't intervene on all of the cases, which high-risk beneficiaries to actually focus on. And following that, we want to do field test and deployment of our work in order to check if our models and algorithms actually work in the field. And perhaps they don't, and so we have to continue to refine. So field testing and deployment is important for understanding correctness of our models and algorithms. But there is more to it. We are focused on AI for social good, for social impact. And if we are doing AI for social impact, we actually have to show that we have achieved social impact. Otherwise, it is not AI for social impact. And so this deployment or field testing is really a crucial element of our research. A second point that is often not understood is that in many of these domains, we're working with marginalized communities. We're working with low resource environments. And as a result, lack of data is a norm. We talk about swimming in big data, but that's not always the case. In fact, in many of these domains, we have to make sure that lack of data is handled as a part of a project strategy. It's a feature of the domain, not a bug. The third common theme, we talked about multi-agent systems data to deployment pipeline. The third common theme is the idea of interdisciplinary partnerships. All of the work that I have discussed is in collaboration with nonprofits. We want to understand their problems and then deploy our solutions with their help and have them as partners throughout. And this will be an important theme in this presentation. So to that end, we have really patrolled with wildlife conservation agencies in forests in Cambodia and Malaysia, for example. When we were working in Los Angeles with homeless shelters, we spent time in the shelters trying to understand the challenges they face. And here are some nonprofits that we've worked with throughout the last 15 years or so that I've been engaged with in order to continue our work forward. So key takeaways from the lecture, and you can, these are the main points of the lecture. First, I'll talk about AI for social good, pointing out that public health and conservation are key focus areas in our work at Google Research Bangalore. Second, that stakeholders, nonprofits, for example, have been involved from the start in AI for good solutions. We don't develop solutions and then go look for problems. Third, when we talk about responsible AI for social good, it is about the entire data to deployment pipeline. It's not just about being responsible only in the machine learning component. Right from the data all the way to deployment, it is important to abide by these principles of responsible AI. And finally, in order to accomplish this responsible AI for social good, we really need a collaboration between AI systems and stakeholders. So with that in mind, I'm now going to describe some of the work that we've been doing at Google Research India, and then come towards the end at what I mean by responsible AI within these and some of the challenges. I'll focus more on the first part of the presentation here and just briefly touch on some of the challenges we face towards the end. So our work started in November of 2019. The lab opened in September of 2019 in Bangalore. And we held a workshop that brought together nonprofits, non-governmental organizations, academics, and Googlers. From this workshop, 25 proposals were submitted as teams of nonprofits, academics in India, and Googlers, from which we selected 6 separate projects as projects that we will push forward. These are in public health, and I'll describe. Swasti is another nonprofit that we've been working with. In conservation, I'll focus on the one with the Wildlife Conservation Trust. There's excellent work also in education with respect to machine translation in Storyweaver into languages such as Konkani and Maithili. Our academic partners are IIT Madras, IIIT Delhi, and others. And there was some coverage of this work, as you can see. So I'll focus first on the work we've been doing with Arman. This is joint work between ourselves at Google, with Arman, the NGO, and my colleague and friend, Dr. Ravindran from IIT Madras and his students. So Arman is focused on maternal health in India. As we may know, a woman dies in childbirth every 15 minutes in India. India accounts for more than 11% of maternal deaths globally. And 2 children under age 5 die every minute in India, and so on. So these are issues that Arman has been dealing with. It's been an inspiring journey to see what they've been doing. And it's an honor to be working with this nonprofit. Their goal is to reduce maternal, neonatal, and children mortality and morbidity in underprivileged urban and rural communities. So one program they run, and they have many other programs, is called Mitra. Basic idea is that women during pregnancy and after childbirth until the child is about a year or so old, they call the woman every week, once or twice a week, to deliver healthcare messages. For example, you are in the 6th week of pregnancy, you should take this kind of iron tablets or what have you. Or you are in, your child is in 3 months old, please register in this government program, etc. So these messages are delivered in local language, in friendly voice of the local health worker every week. And what they have shown in randomized control trials is that leads to increase in the health of the baby, improvement in the health of the mother. And so this is a good program that leads to good health outcomes. Unfortunately, one challenge they face is that there is a significant dropout rate. So women may drop out of the program, thus not being able to avail themselves of the benefits of this program. So the issue for us is, how can we predict which women are going to drop out, which beneficiaries are going to drop out of the program ahead of time, so that we can intervene on them and prevent them from dropping out of the program. So here's how the problem can be understood. Consider beneficiary number 1, a woman, a pregnant woman, who Mitra is calling in the first week, and as shown here, first week there is no pickup. The beneficiary only does not listen at all. But the next week 2, week 3, week 4, and week 5, this beneficiary picks up the phone and listens. Beneficiary number 2 picks up the phone in week 1, week 2, but does not pick up the phone in week 3, picks up the phone in week 4, meaning she listens to the health message, but does not listen to the health message in week 5. So this beneficiary didn't listen to messages in week 3 and 5, but listened in others. And so on and so on. So you can see that different beneficiaries, different women, may have different patterns of when they pick up the phone to listen to the health message and when they do not. Now, there's hundreds of thousands of such enrolled women. The challenge is that some of these women are going to drop out of the program. And one idea would be to just wait until they completely drop out, they don't pick up the phone for several weeks, and then try to recruit them back into the program. But of course, that would mean that they have not listened to these messages for several weeks, and also that it's very hard to get them back. So for example, here, it may be the case that beneficiary number 2 and 4 are the ones who eventually drop off, but beneficiary 1 and 3 continue. In the scale of hundreds of thousands, you can imagine that if 20 or 30% of the women drop off, it's a large number, and it's very hard to predict who these are. Our job is, by looking at who is listening to what messages and how long they have listened to each phone call, predict which of these women are going to drop off. So for example, if we could predict in advance that woman beneficiary number 2 and 4 are the high risk ones, the ones that are most likely to drop off, then Arman could personally call them beforehand, before they drop off, to prevent them, to encourage them to not drop off. And that's the challenge that we faced. And so with our colleagues at IIT Madras, we build these architectures in order to make these predictions. I'm not going to have time to go into the details of this, but essentially, following a lot of testing in the lab, we ran a pilot, looked at 18,000 beneficiaries, enrolled women in Mitra between November and December of 2019. And then we made predictions about the drop-off in January to April of 2020. And what we find is that our predictions are accurate in terms of recall and precision and other kinds of machine learning scores. And so, having seen the validation of the pilot, we have now deployed this system into production to enable Arman to make predictions about which women are going to drop off. and therefore call them before they drop off rather than after they drop off to prevent them from dropping off in this avail of benefits of the M-Mitra program. So this is a collaboration, as I said, between ourselves at Google, Arman and IIT Madras, and we can, this is the kind of prediction results that they get. And so this is an interface that has been built. As I said, the system has been deployed. Now, so far our focus here has been on prediction, making predictions about which of the cases are high risk of drop-off. The next step that we are now working on is prescription. Having identified which women are at high risk of drop-off, figuring out which of these should be called, because even if we can make good predictions, if 30% of the women are dropping off, that's still tens of thousands, possibly, thousands of women. And so there's no way we can actually call all of them. So which of them do we actually call? And some of them have to be called repeatedly, and this would have to be based on their retention probability. So some who are going to automatically return because they have a high retention probability, for example, maybe we don't need to call, or some who have completely lost to us, maybe we cannot call them. It's only some particular group of women that we may wish to call again and again to ensure that they are retained. So this is work that's ongoing, and we will be also including this in our system. So this is Arman. I'm going to very briefly touch on some of the other work that we've done. This second one is with an NGO called Khushi Baby. And this is work done with Singapore Management University, Professor Arunesh Sinha, and ourselves at Google. The challenge that they have focused on, and this is something I mentioned earlier about data being a scarce resource, is the data quality problem. ASHA workers and ANMs or health workers collect a lot of data about female health, and this is Khushi Baby is active in many locations in Rajasthan. And so one of the basic issues that is faced in there and around India is the data collected is sometimes of poor quality. And the question is how to measure data quality based collected by an NM. And the data quality issue can arise because the instruments are not quite right there, the amount of training, the overburdening, etc. So can we predict NM behavior with respect to data quality? So if we can tag that this kind of data first has low quality, or predict ahead of time which data may be of low quality, then perhaps we could we could intervene and ensure that the data gets collected properly, or other ways trying to ensure high quality data is generated. Now, previously, this was done by hard-coded rules. So there were 18 rules that were used, like, for example, if all entries, or if, say, 50% of the entries for blood pressure are always 120 over 80, then that may seem like there's something suspicious going on the data. And so if you see such entries, then maybe this data is poor quality and should unacceptable. We want to be more flexible. And so the work that we've been doing is softening the hard rules. The rules are converted to probabilities. There's basically, for each of those rules, there are 18 probabilities. So essentially, instead of having these hard rules, we have softer probabilities that are used. And then we cluster these ANMs based on the probabilities in order to figure out which of these have low quality data and which are higher quality data. The point here is that rather than harder rules, if we convert them into softer probabilities, we are able to more accurately make classifications of the data and also make better predictions about which ANM is likely to experience this lower data quality. And again, we have completed a successful pilot based on previous data that was collected by our colleagues at Khushi Baby. We are able to make predictions about accuracy of the quality of the data collected, and show that for July and August of 2020, which is just now, that our predictions are fairly accurate, as shown here by recall and precision numbers. And this system is now going into production, meaning that we will be able to make predictions about high and low quality. I'll very briefly touch on a third project, which is on by Wildlife Conservation Trust, again, a collaboration with Professor Pradeep at Singapore Management University. And so this is a problem of predicting human-wildlife conflict. As we know, most forests in India are multi-use instead of being protected areas, so wild animals and humans cohabit. And so what this means is there is plenty of scope for conflicts. And WCT, Wildlife Conservation Trust, is active in 160 protected areas, and the job, one of the projects they work on is trying to prevent this human-wildlife conflict. So here's from Maharashtra around the Tadoba sanctuary. You can see the plots of livestock kills and injuries, as well as, so you can see that there's lots of such incidents. If we can predict in advance where this conflict is going to occur and prevent it, then that would obviously save cattle and save human life. And so that is what we've been working on with WCT. And this is work very much in progress, and hopefully a successful pilot will be shown soon and move the system into deployment. So what I've discussed with you so far are some of the projects that have been ongoing at Google Research India for AI for social good. What I want to discuss next is responsible AI for social good. Of course, we want to make sure that we work with Google's AI principles, and we've obviously tried to work with these. As you can see, Google's AI principles include being socially beneficial, avoid creating or reinforcing unfair bias, being accountable, upholding higher standards of scientific excellence, and not pursue applications that will likely to cause overall harm, and so forth. Now, by just being in these domains where we're focused on AI for social good, we are focused on being socially beneficial. But some of these AI principles lead to some very interesting research challenges that need to be addressed as we move forward. And this leads to some interesting challenges. Let's look at the challenge of fairness to avoid unjust impacts related to race, ethnicity, gender, nationality, and so forth. Now, so far in the field, what we find is that unfairness or fairness, avoidance of bias is based on the predictive model, purely on the machine learning, making sure that there is no bias introduced in the machine learning. However, when we talk about AI for social good, as I said, we focus on the data to deployment pipeline in full. And it's not enough to only ensure fairness in prediction, only be responsible in the predictive model. We need to be responsible. We need to have fairness in all parts of this model. So the prescriptive algorithm also needs to ensure there's fairness in interventions. If, for example, in Arman, we are going to call women in order to ensure they remain in the program for sort of customer retention, beneficiary retention, then if we purely, it is feasible that by purely looking algorithmically at probabilities of retention and so forth, that we may favor a particular category, women of a particular age, or women in a particular geographical area, women who speak only one kind of language, because that's where we are more effective. And this may lead to unfairness towards other groups. And so we want to ensure that there's fairness in interventions. Our papers at NeurIFS 2019 and ICHCAI 2019 to AI conferences go into more technical details. Obviously, we'll not have time to go into that. So I see that I'm coming to the end of my time. So here's the main takeaways from my lecture. In AI for social good at Google Research Bangalore, we've started several projects. In the future, we will start many more. Our main focus areas have been public health and conservation so far. As you can see, stakeholders, NGOs have been involved from the start. You can see in all of our projects that nonprofits are there at the beginning. They pose the problem. They are there at the end when we develop the solution and deploy them. They're there throughout with respect to the pilots in giving. So it's a very collaborative development of the solution. Responsible AI for social good is about the entire data to deployment pipeline. We can't say that we will only be responsible in the machine learning portion and not others. Whether it's intervention, whether it's deployment, data collection, entire part, we have to be responsible. We have to have these principles of responsible AI being developed, being focused on. And finally, that this requires us to have a collaboration between the AI system and stakeholders. It cannot be the case that the AI system by itself can address these challenges. It may not even know about some of the challenges in fairness, the history of the society and so forth, as a result of which we want to ensure fairness towards one group or another. And so this is something that there's a socio-technical problem. It requires us to really have humans in the loop throughout. And so that's where I'll end. This is joint work at Google Research India with several of my colleagues. I wanted to make sure I acknowledge all of their efforts, in particular Manish Gupta, who's the director of the lab, as well as my colleagues Alok, Ashish, Divi, Dhyanesh, Gaurav, and others. So thank you very much. That's the end of my presentation. Appreciate your listening in. Thank you. Bye.
Thank you, Professor Milind Tambe. That was fascinating, a great, beautiful journey into a topic that is going to be deliberated further and moderated upon by our panel and by our esteemed moderator. For me, I think it was particularly fascinating because we are beset with exactly the type of problems that you have taken up in your research. We have 115 of our 715 districts as aspirational districts in our country, which are among the bottom of the pyramid in terms of basic access to healthcare, education, affordable housing, clean drinking water, sanitation, and so on. And these are perfectly the type of problems that need to be addressed. And there is a great opportunity. And you very systematically brought out how important it is to involve various stakeholders when you are developing AI for social good, how important it is to have a comprehensive approach from data to deployment, and the opportunities for research in each of those areas, the immersion area, the predictive modeling that you have to do, the prescriptive algorithms that you develop, and the field testing, where you have to collaborate again with the stakeholders so that you are seeing the results of the system. You also brought out very beautifully the importance of preventing bias and having a set of basic principles using which you develop your AI solutions and you do the necessary research. And finally, you also gave 3 outstanding examples and of actually how you are trying to leverage these basic principles in the research being done. I think it has set the framework for a very interesting panel discussion. Thank you so much for your presentation, and I am sure there will be a lot of questions for you directed towards you also as a part of the panel. Now, let me take the pleasure of introducing the panel. First and foremost, the moderator, Professor Balaji Parthasarathy. He is going to be the moderator. Thank you, Professor Balaji, for agreeing to be a moderator for this session. Professor Balaji is a PhD from the University of California, Berkeley. He is a professor, International Institute of Information Technology in Bangalore. His research and teaching interests broadly focuses on the relationship between technological innovation, economic globalization, and social change. In January of 2020, Professor Balaji Parthasarathy was recognized as a fellow of the Regional Studies Association of the United Kingdom. Samuel von Pufendorf, visiting research fellow, Pufendorf Institute of Advanced Studies from Lund University in 2017 and 2018. He has done his academic writing residency at the Rockefeller Foundation Bellagio Center in Italy in 2015. He's also the Emerging Leader Fellowship, Australia India Institute, University of Melbourne in 2013. He is the Linnaeus Palm Faculty Fellow, School of Arts and Communication, Malmö University, Sweden in 2010. Several other accomplishments. It is really an honor to have him as a part of the moderating session, as a moderator for the panel session. The other panelists are Professor Amit Sethi, who is a PhD from Illinois in electrical and computer engineering and bachelor's from IIT Delhi in electrical engineering. He is an associate professor, Department of Electrical Engineering, IIT Bombay, where I graduated from. So it's great to know that you're right now a professor of Department of Electrical Engineering in Bombay. His research areas include computational pathology, medical image analysis, deep learning, computer vision, image processing, machine learning, pattern recognition, signal processing, and algorithms. He is one of the 5 finalists for for NVIDIA Global Impact Award 2017 based on the work on computational pathology. He is also the Indo-US Science and Technology Forum Fellow to work on prostate cancer prediction at UIC in 2014-15. He is a Microsoft Young Faculty Award winner in 2011. We are also delighted to have Professor Mayank Vatsa, who is a Master and PhD in Computer Science from Lane Department of Computer Science and Electrical Engineering at West Virginia University. He is the Professor of Computer Science at the Indian Institute of Technology, IIT Jodhpur. His areas of interest include biometrics, image processing, machine learning, deep learning, image forensics, and information fusion. In 2018, he was selected for the prestigious Swarna Jayanti Fellowship Award and many others. We are also delighted to have Dr. Moninder Singh. Dr. Moninder is a PhD in Computer and Information Science from the University of Pennsylvania in May 1998. He is the research staff member, IBM Research, Thomas J. Watson Research Center, Yorktown Heights in New York, USA. His research areas include machine learning and data mining, artificial intelligence, data privacy, information retrieval, probabilistic modeling and reasoning, and text mining. He is an IBM Outstanding Technical Accomplishment Fellow for Trustworthy AI in 2019. He's also been recognized by IBM Research in the accomplishment for cognitive skills transformation in service delivery organization in 2018. He has won several other awards from IBM in 2016, and he's also an IBM Outstanding Technical Achievement Award winner in 2016. So we are delighted to have a very distinguished panel here, and I'm sure you're going to have an equally more scintillating, engaging conversation on research in artificial intelligence for social empowerment. I hand it over to Professor Balaji for conducting the session.
Thank you, Mr. Ramanan. Am I audible?
Yes.
Okay. Okay. So it's indeed a privilege to be called upon to moderate such a fine group of panelists, fellow panelists. It's interesting because they're all very accomplished computer scientists in various departments. And I'm actually a lapsed technologist, right? I abandoned technology more than 30 years ago and moved to the social sciences. So what I hope to do is to really, in a sense, provide a sort of a provocative counterpoint. Much as I'm a deep admirer of technology, it also raises certain questions about what we mean by responsible AI, what we mean by sort of socially relevant technology, and so on. And so I just want to have this kind of discussion around these questions that remain deeply unanswered. And I think it's very fascinating. It's a very fascinating coincidence that we are having this discussion today about something that is new, whose implications are phenomenal, but all those, we've yet to understand all what the consequences of all those implications mean, because it is only today that two outstanding chemists were awarded the Nobel Prize in Chemistry for DNA editing, right? DNA editing, like Jennifer Doudna, who's one of the sort of awardees said, often offers all kinds of fascinating possibilities. But it's like many other things, it's like a double-edged sword, because if it falls into the wrong hands, if it could be misused, it can be misused in a variety of ways. I think in a sense, AI, we are probably sort of sitting in that kind of a cusp and sort of figuring out what is it that we mean by social good, what is it that we mean by responsible innovation, how can we sort of conceptualize this and harness this for for the betterment of the human race in a variety of ways. And I think Dr. Tambe in his presentation showed us various ways in which we can actually think about it conceptually, practically across a variety of domains. So what I'd like to do now is actually, I've put together for the panel a set of sort of questions, and I'd like Prasoon to share the screen and share those sort of questions up front, and then we'll open it up for a discussion among all the panelists. So what I've done here is to sort of come up with a framework, because there are any number of questions that one can ask. I've drawn upon the work of the, can I have the next slide, please? The first slide. I've drawn upon the work of the very distinguished technology, science and technology historian, Melvin Kranzberg. I think that's number 2. Can you go back to the first one? Yeah. Next one, please. Sorry. Yeah. So I'm drawing upon the work of Melvin Kranzberg and to sort of help us think about the, what AI means or what it can mean for us. First, Kranzberg, wrote a wonderful paper back in the 80s when he talked about, science and its science, technology, and its relationship to society. And he came up with what came to be referred to as Kranzberg's 6 laws. Okay? And the first one is, all history is relevant, but the history of technology is the most relevant. So, the implications for us is, we've had, why is it that we're talking about AI today? I mean, we're talking to a general audience, obviously, for computer scientists, they're immediately aware of why is it that they're talking about it. It's useful to sort of historically situate the current sort of debates, the excitement about AI, when it's been around in some form or the other, especially since the 1960s. And in fact, if you go to the website of this particular conference, Dr. Raj Reddy said it's something we've been doing for the past 5,000 years. I didn't quite get that, but nevertheless, it's not something that new. So it's worth actually asking ourselves and sort of, why is it that we're suddenly excited about it in a way that maybe didn't happen even 15 years ago? Next, please. Okay. Now, the next is, invention is the mother of necessity. So, when we talk about AI, we actually refer to not one, but a basket of technologies, which is also why, people refer to it as part of leading a 4th industrial revolution. It's what economists call a general purpose technology. It has applications like Dr. Tambe pointed out in conservation, in education, and healthcare, and so on and so forth, right? So I would like the panelists to say, like, when you refer to the term AI, what is it that what does it mean for you in your own area of research? And we'd like you to sort of explain it in a very accessible form for the audience. Next, please. Okay. The third thing is, Kranzberg said technology comes in packages, big and small. In other words, it's not just a set of techniques, right? It just, it has sort of reverberations across other areas. That's why we call something like AI a general purpose technology, which then leads us to ask the question, why is research essential for AI? I mean, what are the major issues we need to explore and understand? And for whom is this research and who is to actually conduct it? Now, let me just pick up on something that, Dr. Tambe said. For example, he gave this wonderful example of, conservation, for instance, or the larger issue of, Google Labs working with NGOs. Now, if we ask ourselves, what is it that we typically mean by research? For most of us, especially for academics, research means at least 3 things. We think of research through, a body of theory, which sort of sheds light on how the world works, right? And then when that body of theory proves to be inadequate in some sense, then we go looking for evidence. We go looking for data to say, okay, why is it that where is it that the theory actually falls short? And then to sort of reconcile that, we look for a set of techniques, tools, etc., so that we can integrate that and we have a more sort of a holistic body of theory. Now, in this particular case, or in the case of any general purpose technology, you have the emergence of something like AI, which itself offers a new area of research, right? And that research, if it's going to have any impact, you then say, okay, can I apply to another area like conservation or to another or to some other domain so that we are actually able to make an impact? But one of the things that I would like the panel to discuss, and maybe you and Professor Tambe can shed light on, is, where is it or how is it that we are actually contributing? We may actually be contributing to the algorithms. We may, we're able to get more robust algorithms that are able to make predictions better, etc. But how is it that we're actually able to contribute to a body of knowledge, a body of theory? It might be in public health, it might be in conservation biology, etc. So what is the nature of that relationship? I think that's something we need to explore if you're talking about something like AI. The next slide, please. Yeah. So then Kranzberg says, although technology might be a prime element in many public issues, non-technical factors take precedence in technology policy decisions, right? Now, if you look at it historically, all technologies have been double-edged swords. That is, they deliver benefits, but they can also cause great harm, right? And I gave you the example of sort of the DNA splicing, and then so the question then is, what are the expected benefits from AI? And there's been a lot of excitement, to be sure. But the other aspect of this is, what potential harm can we actually expect beyond talking, at a level of generalization? Yes, we should not harm particular groups, etc., etc. But from your own research vantage, what is it that you would not like to do, or how is it that you would sort of ring fence the research in a manner of speaking that you're able to insulate damage? I mean, there's no guarantees, but nevertheless, are there sort of precautions that we can take? Next. Yeah. Then technology is a very human activity, and so is the history of technology. So that means, what is it? And the implications are, what is meant by responsible AI, and who is it responsible for? Can we distinguish between responsibility in production on one hand, in the labs, in the corporations, etc., and in its consumption, the people who are actually consuming it in a variety of demand? How do you actually consume that technology in a responsible fashion? Right? And finally, one last slide, the sixth of Kranzberg's principles. Technology is neither good nor bad, nor is it neutral, right? So which leads us to the final sort of question, like, is there something like irresponsible AI? And can our research actually help identify or mitigate against it a priori, rather than waiting for the damage to happen and then doing damage control? So, which then says, when would you advocate not using AI? I mean, are there problems you say, look, this is something we can apply, it's going to do us a lot of good, but these are areas, there are other ways to do it, maybe simpler ways, maybe other approaches are possibly better advised. So this is a sort of a question, or a set of questions that I'd like to now sort of open up to the panel, and feel free to jump in and start anywhere that you want. You don't have to follow these questions either in this sequence, nor do we have to stick to these questions. If they open up new areas for discussion, that'll be wonderful. So is there somebody who'd like to actually volunteer to respond to any of these questions, or to sort of take the lead?
Professor Balaji, I just wanted to say thank you for this excellent set of questions. Could we just very quickly scroll through them once, because I want to be sure I remember all of them.
Please go ahead. I mean, and thank you for that, Dr. Tambe, because it's not very original. It's all owes to Melvin Kranzberg. It just happened that I read his paper a few years ago. So may I ask Prasoon to scroll through, because I can't. I'm not doing it from here for bandwidth reasons. Yeah.
Yeah, you could go through it quickly. It's fine.
Yeah. So the question is, why are we talking about AI? I mean, I'll just talk about in the context of this panel, and then in the context of your own work, what does AI mean? Because when we're talking about a basket of technologies, and so what does your own work refer to? Number 3. Next. And then, why is even research essential for AI? What are the major issues that we need to explore? What do we need to understand? For whom is this research for? Why do we conduct it? And who's to conduct it? Right? I mean, why are we giving ourselves certain legitimacy to conduct it? Let me put it that way. And then, all technologies have been sort of double-edged swords. Whether it's flight, automobiles, everything. So they can deliver benefits and cause harm. What are the benefits from AI? We've talked about some of those. We know about some of those. But what potential harm can be caused? And we'd like to go beyond generalizations. Next. What do you mean by responsible AI, and who's responsible for this? Can we distinguish between responsibility in production and in its consumption? And here again, there's one point that I'd like to make. There are some of us on this panel who are pure academics. Some of like Dr. Tambe and Dr. Moninder Singh stride academia and the sort of the corporate world. So, for example, there's a whole question of intellectual property. Right? Who will hold this? We say we want to do this for the public good, for social good, etc. But then, from a corporate point of view, there's this whole question of IP that's always sort of the gorilla in the room, in a manner of speaking. So how do we think about this? Can we release it? When you have machine learning algorithms, when the algorithm itself sort of evolves over a period of time, do we patent it initially? The end result is what evolves over a period of time may not be what we started off with. So this is one set of issues. Next, please. Okay, is there something like irresponsible AI, and can research help identify or mitigate it? When would you not advocate using AI? Are there a set or a class of problems you say, guys, let's not, merely because we have a hammer, everything shouldn't be a nail. Let's avoid doing certain things. So this is what I would like to present to all of you. Anybody can take the floor. Yeah, so, yeah, please, Dr. Sethi.
Can I quickly? There are some visuals that might help.
Yeah, please go ahead. Please.
Thank you. Can you see my screen?
Yes.
Okay. So for the audience, let me give a very 30-second introduction to what is AI. So let's say you want to estimate, you want to predict something based on some input, right? You want to predict an output based on an input. So let's say you want to predict someone's height based on their age. There might be a formula for that, right? So the height keeps on increasing initially, and then it tapers off, and then that takes certain formula that so I'm sorry, as an IIT professor, I have to show you a formula, but so bear with me for a second. So now in this formula, there are several unknowns which we call parameters, right? So what is how fast does a person grow with age, and at what time do they taper off, and all that. And those things, in traditional statistical sense, you would collect a lot of data and you would fit a model to that. Now, what has happened with AI is that with the increase, with the advances in the algorithms to estimate these parameters like A, B, and C that you see on the screen, and with the